All right, guys, we're finishing going up over the review sheet today. So your test is tomorrow, and you will be able to finish the entire test in one class period. So, now the first thing we're going to look at today is these inequalities, solving logarithmic and exponential inequalities. Now, when we start out with a logarithm, the first thing we need to do is get the logarithm by itself. And for this first one here, we have the natural log of the quantity x minus 1 is greater than or equal to 9. So the logarithm is by itself. So we need to put both sides to a base. It would be e. Because the base we put both sides to will match the base of the logarithm. And the natural log's base is understood to be e. So e to the natural log of x minus 1, well, e in the natural log will simplify out, telling us x minus 1 is greater than or equal to e to the 9th. Does e to the 9th simplify to a nice number? Well, we can, e to the 9th is 8,103.083928 going on. Because for the most part, e is irrational. So no matter how many times we multiply e by itself, it is going to stay irrational. Does that kind of make sense? The only way we can make e be a nice number is if we put it to an imaginary irrational number. Well, pi is irrational, yes? What's the imaginary number we know? If we put e to an imaginary irrational number, pi I, it actually does work out to be a nice number. But now we just need to solve for x. So what can we do to solve for x? So x is greater than or equal to e to the 9th plus 1. Questions on how we got to this point here. Now with logarithms, we do need to be careful that what's inside the log, here x minus 1, is not negative or 0. It has to be greater than 0. So we set this up here to figure out what values of x will cause problems. So if x is equal to 1 or less than it, what's inside the log will be negative or 0. So x has to be greater than 1. Okay? Now let's look at the answer that we got. X is greater than or equal to e to the 9th plus 1. Well, is 1 greater than or equal to e to the 9th plus 1? Is 1 greater than or equal to or greater than e to the 9th plus 1? Well, no, because e to the 9th is 300. It's going to be a big number. So is 1 greater than this? Well, no. So that's our final answer. Because if that 1 was included and made a true statement, we need to exclude it. Here, doesn't even matter. Because there's no way, there's no value of x that satisfies our e to the 9th, making this here true, that would cause this to be negative or 0. And there's not going to be one on the test that actually needs this extra piece of information. So, any questions on number 17 before we look at number 18? Log base 7 of x plus 2 is less than 4. Is the log by itself?
No.
So what is with it?
X plus 2.
X plus 2 is inside the log.
So we're going to set a base.
So the log is indeed by itself. We're going to put both sides to the base of 7. Because if there was something added outside the log or something was being multiplied in front of the log, we would have to move it first before we can do the base of 7. Because our log 7 to the log base 7 cancels out, it simplifies out, leaving us with x plus 2 is 7 to the 4th. Is 7 to the 4th a nice number? Well, if we want to check, we can type 7 to the 4th power into the calculator.
It's 2401.
2401. Okay, so that is a nice number. So we're saying that x plus 2 is less than 2401. Question how we got to this point here. Now we do need to solve for x, so we can do what? Minus 2 from both sides. Telling us x is less than 2,390.
The watch left side.
Now, x plus 2 has to be greater than 0. So x has to be greater than negative 2. Now in the problem, the final answer that we had was that x is less than 2,399.
So that'd be the answer, because it is.
Is negative 2 less than 2,399?
Yes.
Because is negative 2 less than this number here? Yeah. But if the value of x is less than negative 2, it would cause what's inside the logarithm to be negative or 0. So we have to add this restriction that it has to be bigger than negative 2. So this is our final answer. So negative 3. Is negative 3 less than 2,399? In our original equation, log base 7, I plug it back in. So we're trying to see if log base 7 of negative 3 plus 2 is less than 4. Well, negative 3 plus 2 is negative 1. I cannot take log base 7 of negative 1. Because if we do math.
So if the statement for the restrictions isn't true, then we don't have to add anything to it. It's just the answer.
Yeah.
Okay, that makes sense.
Now, log base 7 of negative 1, it did give us an answer, yes? But what's at the end of that decimal?
So
I.
it's an imaginary number.
It's an imaginary number. It doesn't work. We can't take log base 7 of a negative number or 0. But negative 3 did make our original statement true, yes? Now, when I put this here that negative 2 is less than x, so is negative 2 less than negative 3 less than 2,399? Well, no, because negative 2 is actually bigger than negative 3, yes? So it's not true anymore. That's why we needed this. Now, this part, there's not going to be one on the test that needs it. It's just not going to come up, okay? Because they're more going to, especially with our inequalities with logarithms, they're going to be more like 17 in our final answer result than they are as 18. Not the steps, just the final answer having to add the additional piece. Questions on this here? Number 19, 6 times the natural log of x plus 7 is less than 60. Is the natural log by itself? No. So what do we need to do first to get it to be by itself? Subtract 7. We always want to do addition, subtraction before we do multiplication, division. So it'll tell us 6 natural log of x is less than 53. What do we need to do next?
I'm sorry, well, I was writing stuff down.
You're good.
Make notes of stuff. What was it?
What do we need to do next?
Put the x on it. 6 with the x. Put the x on it.
We could, but we're trying to get the natural log by itself first. It's going to be easier to move the 6 first.
Oh, set the base. Oh, gee.
Because 6 and the natural log are being multiplied, so why not divide?
Oh, yeah.
Telling us the natural log of x is less than 53 over 6. Now, we would do our base of e. Before we can do the bases with solving logarithms, we need to get the log by itself. E to the ln is going to cancel, telling us x is less than e to the 53 over 6. Excuse me. Questions on how we got to this here? Now, again, let's just look at this here. X is inside the logarithm. Only term inside, so that X value has to be greater than 0. Now, is 0 less than e to the 56 over 3, or 53 over 6? Well, e to the 53 over 6 is some big number, yes? So, for this problem, we would technically need 0 is less than x is less than e to the 53 over 6.
Okay, so that's what we're getting that.
Mm-hmm.
That x minus, or the x has to be greater than 0.
Yep.
X plus 2 has to be greater than 0. So I was getting confused by that, but now I see.
Yep.
We're just looking at the this or before with the log.
Yeah, whatever's inside our logarithm cannot be 0 or negative, so we have to remove any value that would be the case. Because on 17, there is no value that would be true, because they're already gone. 19, they're still included. Because e to the 53 over 6, second ln, 53 divided by 6, 0 is definitely less than that.
I get it now.
All right. 20. 5 times the log base 7 of 4x is greater than or equal to 160. What can we do first? By? We're going to divide both sides by 5. Because our log base 7 of 4x is greater than or equal to 32. What can we do next?
Set the base.
2.
7.
Put both bases to 7. Because our 7 to the log base 7 of 4x is 4x. Is greater than or equal to. Is 7 to the 32nd power a nice number?
Probably not. Or it might be. 2. Maybe. Yeah. Oh boy.
No, that's way too big. So we'll leave it as 7 to the 32nd. All the times that we have on the test where it's a number to a number, that's not e, it's going to work out. We're going to divide it by 4, telling us x has to be greater than or equal to 7 to the 32nd over 4. Well, 4, because if we looked at the restriction for this here, 4x has to be greater than 0. X has to be greater than, is 0 greater than 7 to the 32nd over 4? No, so we don't need it, because there's no way to make it 0 based off our solution set.
So if we don't add that in there, how many points will we get on the test?
None, because there won't be one. This will not show up on the test.
Oh. Oh. So it's all going to just be straight answers like that?
Yes.
Okay. That makes it feel better. That was going to make me second guess a little bit. So.
Part of the reason I didn't put it there.
Awesome.
Questions on these so far?
Sir.
Number 21. Negative 4 log of x minus 5 is greater than or equal to 3. Is the log by itself? What do we need to do first?
Divide by negative 4. Oh, add 5.
Yes. Mm-hmm. I mean, we could divide by negative 4 first, but we would have to divide everything by negative 4. Because it would give us log of x, but then we'd have plus 5 fourths, and then we'd have negative 3 fourths. So it might be easier to add first. Then we can divide by our negative 4. Negative 4 log of x divided by negative 4 is log of x. 8 divided by negative 4 is?
Negative 2.
Oh, negative 2.
Mm-hmm. What happens to our inequality sign?
It flips.
It's gonna flip because
Wait.
it's not.
Anytime we multiply or divide by a negative, we have to flip the sign.
It's not.
So we have log of x is less than or equal to negative 2. What are we going to put both sides to the base of?
Let's see.
10.
10. Dang it. I was trying to figure out the base.
Whenever the base for log is not written, it's understood to be 10. Natural log, the base is understood to be e. 10 to the log of x is
X.
is less than or equal to 10 to the negative second. Is that a nice number?
Yes.
No.
Let's see.
What's the negative? Oh, no.
Because if the exponent negative, we move it from the top of the fraction to the bottom, which is just 1 over 10 squared.
Just basically 10 squared. 10 squared and then flip them. The denominator.
So x is less than or equal to 1 over 100. Well, less than, that means we do have some restrictions.
It has to be greater than 0.
Well,
Or less than 0. That is true.
yep. So the full answer in the one, especially in the back of the book or the review sheet, 0 is less than x is less than or equal to 1 over 100. Because whenever we have logs and it's less than, unless it's a real rare case, we do need that less than or equal to, or the less than, whatever the number is added to it. 0 is less than x or whatever the number is. But for exponents, like number 22, there are no restrictions.
Same shoes on.
Now, before we start number 22, are there any questions on any of the ones we've done so far today? Now, the nice thing with 22, since it is the x is in an exponent, there aren't any restrictions, anything we have to add, like the previous one, 0 is less than x, because any number can be put in an exponent. Rational, irrational, radicals, any of our numbers. So we don't have to worry about that. Now, for the most part, there's nothing else with our 3 to our variable, 4x minus 5. So we just need to apply a log to it. What log would we apply?
Log of 3.
Log base 3.
Okay, Jeff.
Easy.
Because we want the base of the log and the base of our problem to be the same, because log base 3 of 3 to the 4x minus 5 is 4x minus 5. It's greater than log base 3 of 108. Well, log base 3 of 108 is not a nice number. The only way it would is if 108 could be rewritten as 3 to a power. And since it can't, we're leaving it there. Now we just need to solve for x. So our next thing is 2. Add 5 to both sides. Telling us 4x is greater than log base 3 of 108 plus 5. And lastly, we divide both sides by 4. Telling us x is greater than log base 3 of 108 plus 5 all over 4. Questions on this here? We ready for the next one? E to the 3x plus 4 is greater than 11. Well, E is already by itself. We don't have a number in front of it. We don't have anything added or subtracted to it. So we can go on and apply our logarithm, which would be ln. It would be our natural log, because the natural log's base is understood to be E. So ln of E to the 3x plus 4 is 3x plus 4. Now we just need to solve for x. And the first thing we can do is subtract 4 from both sides. Telling us 3x is greater than the natural log of 11 minus 4. And then the last thing would be 2.
That's crazy. Oh, I'm so behind in Miss Simpson's class. It's not even funny.
Questions on 23. We good with 23?
I can't write as fast as you. I try to make notes so I don't forget this stuff.
Mm-hmm.
I did on one. I did it on most of them.
Actually, that's two. All right.
And again, having those are helpful.
Yeah.
Because
I'll think. Most of the time I'll be like, oh, I'll remember that, and then when I get there, I'm like, I know I was gonna remember something. I don't remember what it was.
yep.
For the test,
So I don't remember.
we have to enter things in the calculator and also run into it. Insert in calc.
I mean, sometimes it might be helpful to put some of the steps.
Yeah, I just like.
Because again, the review sheet, I know y'all are pretty much at the end of this, but I would treat review sheets as, especially if you use them on, are able to use them on the test, as hints and guides, not so much as it's more of a backup plan than it is anything else. Because the review sheet, even if you can use it on the test, I'd treat it like a spare tire. Use it if you need it, but hopefully you won't need it. 4 to the x. Our number to a variable is already by itself, so we can apply a log to both sides. What log would we apply?
Log of 4.
Log base 4. Log base 4 of 4 to the x is x. X is less than or equal to log base 4 of 36. Is x by itself?
Yes. So we're going to only stop if the x is by itself.
Yeah. Because the only reason we had to keep going on the last one was, well, it was 3x plus 4 is greater than the natural log of 11. We don't know what the value of x is, so we have to keep going. Questions on this so far? 25 through 28, these were technically on the last, or on the, we covered this before the last test, but I'm throwing them on here because this will be some nice points to get. Because our change of base, log base b of m, is equal to log of m over log of b. Whereas a natural log, be ln of n over ln of b.
Could we just enter it?
So we're not going to have to evaluate it at all on the test. I'm looking for you to be able to write it as common log or in logarithmic and natural logarithmic form. Now when we do this here, what's inside goes on top, inside the logarithm on top. The base goes inside the logarithm on bottom. So what's inside our log for number 25?
Would be log of 96 over log of 8.
Yeah.
I'm sorry, I'm writing stuff down.
So log base 8 of 96 as logs would be log of 96 over log of 8. Questions on this here before we look at natural logs? Now the natural logs would be the natural log of what's on top over natural log of the bottom. So it's the exact same thing.
Oh, I do remember that.
I don't remember this.
Because the change of base lets us change the base to whatever we want, either base 10, as the first one we have, or base E.
If you was like,
I do remember that.
yes, I'm just interested.
Let's look at the next one.
What?
Log base 12 of 8 would be rewritten as what? Log of?
8 over 12.
Log of 8 over log of 12. Natural log, it would be the natural log of 8 over the natural log of 12.
Oh,
Question on 25 or 26?
No.
We good with these two here.
I'm not even kidding. I did this class. Why? I literally this class, but
It was so quiet in science. Yeah. I know, I could actually sleep.
that's crazy. No, that's not that bad.
We ready for the next two?
Yes.
Sir.
So log base 100 of 2 would be what?
Log of 2 over log of 100.
Log of 2 over log of 100. We'd also have the natural log of 2, natural log of 100. And lastly, log base 1/8 of 9/7 would be log of
9/7
7.
over log of 9. Or log of
Man, come on.
whatever.
Or it would be the natural log of
Oh, yeah.
9/7 over the natural log of 1/8.
Everyone just used to say that. I thought it was so funny.
Yeah.
And that's it.